Implicit differentiation. A long word on a Friday morning. Yeah. And guys, does everyone understand if you see the word differentiate, that just means take the derivative? That's another starts with D's, you know. They all mean the same thing. So guys, implicit is just another way to find derivatives. And we're going to look at what you've been doing is called explicit differentiation. So let's look at that first, just to remind you. So let's say I had y equals x squared plus 5. And remember we had all these different notations like y prime, f prime of x, dy dx. Those all mean derivative. Okay? So today I'm going to write the dy dx. Would just be 2x, right? What that's telling you to do is take the derivative of y with respect to x. Okay? Just means derivative. When there's a single y to just the first degree, that's what you're doing. You can use all your power rule, quotient rule, chain rule, all of that stuff, but you haven't really had to worry about the y at all. Implicit, we just add in the fact that you have to think about y. So let's look at our first implicit. So let's say we now have y cubed equals x squared plus 5. All right, so clearly looks a little different than what we've been doing, right? Our y is cubed. So the way you start this, use your power rule just like you normally would. So y cubed, what do you think the derivative of that would be? 3y squared, okay? Because we're looking at dy dx, like we're taking the derivative of y with respect to x, anytime you're doing the derivative of y, you will also have times dy dx. Okay? And then what's the derivative of the other side of my equation? 2x. And what do you think we're actually solving for here? Yeah, dy dx. So what would dy dx equal? There you go. That's it. Not that bad. Yes.
That's an odd question.
So, I don't really know yet. Like, you're going to need it in calculus. Right now, just accept that you need it in calculus. I promise I'll explain more. But it has everything to do with finding the slope. You know, everything isn't going to be just a happy y equals x squared. You know what I mean? We can have weird things like this. Okay? Yes. Yep. That's really the only part that's different. Okay? Yes.
So the only thing that's different is the fact that y is
Yeah, that we have to like do something with our y. We can't just say, oh, y equals, find the derivative, we're done. Like you have to do the derivative of the y.
So when you make both sides, that's what makes it implicit.
Because it's not just a linear y. That's all. Okay, let's try again. So y cubed minus 2y plus x cubed equals x squared plus 2. I want you guys to try. There's no product rule, quotient rule, chain rule, anything in this problem. It's just straight power rule, but you do have the y's to deal with. Okay? So I'll give you a minute here. You take attendance.
Yeah.
Wherever there's a y, there's dy and dx.
Yep.
What? For every single
Wait, is it wherever there's y, we're at?
While you're taking the derivative, so like y cubed is going to become 3y squared dy dx. Okay, so what would the derivative of 2y be? 2 dy dx. Okay, and then keep going. Okay? Eventually, but no, it's fine where it is right now. Was that a y?
Yeah.
Okay, so now, yeah. Keep it simple here.
That's right.
Give me another minute here. You're annoying. Just angry this morning. Oh, bye. What?
How's your day going?
It's pretty good. Today's gonna fly by. I have 5th period planning, so I'm like done teaching at 10:50, but I have a lot to do before that.
Well, yesterday.
Yesterday, I took the day off. I know. It was so nice. But then the reality, it's like you know, if you miss a day of school, how much work is waiting for you? Yeah, same. Like, you know, all of your tests. All right, guys, you ready to look at it? So this would be 3x squared, and this side would be 2x, right? Okay. I'm going to do this in one step. Tell me if you're not okay with this. Brilliant. I probably could have just gone straight to the answer and you guys would have been okay with it.
Oh my god.
Yes?
Yeah.
Okay? Is it that bad? All right, let's try again. All right, find the slope of the tangent line. Yeah, 11.3 is stricter. It's just like understanding, oh, the sine is this. They're all related to each other. And we'll look at it graphically. At the point root 2, comma, -1 over root 2. This has nothing to do with like sine or cosine or unit circle or anything, okay? 4 x squared plus 4y squared equals 4. Do you want to try or do you want me to walk you through it? Okay, try it, yeah. You can do each other. What does your brain tell you when you see slope of the tangent line? That should automatically be like, oh, I need to find the derivative. So start there.
got 1/2. No, I got 1/2.
I'm hearing a lot of people say I got 1/2. That is the right answer. Okay, let's find the derivative first. Right, guys, is that automatic in your brain now? When you see slope of the tangent line, you're like, okay, you gotta take the derivative. Yes? Okay, that's good. We're there. All right, so I would do 2x. And then this would be 8y dy dx, right? 0. So if I'm solving for dy dx, that's just going to be negative 2x over 8y, which is the same as negative x over 4y. Yeah? Then I've given you this point, so I should just plug those values in. So we'll go over to the side here. So negative root 2 over 4 times negative 1 over root 2. Okay? Now it's just simplifying. So it's negative root 2 divided by negative 4 over root 2. Well, when I'm dividing by a fraction, what am I really doing?
Multiplying.
All right, so what's root 2 times root 2? 2, I got 2 negatives, so those are gone. So I've got 2 over 4, which is 1/2. So the slope of the tangent line to this graph is 1/2 at that point, okay? Not that bad? Doing okay? All right. We're ready for another one?
Yeah.
All right, we are going to find the second derivative. Okay? Oh, and that's not, I wrote it wrong, guys. I know this seems weird. For right now, you just have to accept that 1 squared is there, 1 squared is, like, that's just how you write it. You'll learn why later. I know it's annoying. Just for right now. Probably this year. Okay. Later in life.
What if I don't want to know why?
That's okay. For today, that's totally okay.
Why can't they just tell us?
Well, it's sort of fun to hold you in suspense. No, I'm kidding. Because I only have 20 minutes left of you, so. All right, guys, we're going to do this one together because something's different in this one. What is different? They're multiplied together, right? So what do you think I have to use? Product rule. Okay, so guys, those product, quotient, chain, all of those rules that you've learned before, you may have to use during your implicit. So, derivative of 1, that's easy. So really, we just need to think about the derivative of this. So that's going to be y times, what's the derivative of this piece? Negative 1? Yeah, okay. Plus, then it's going to be negative x. All right, the derivative of y.
Wait.
Yes. Product rule? I'm doing the product rule of negative x times y. So, second one times derivative of the first plus first one times derivative of the second. That's the dy. Okay?
Derivative of y.
Yeah, so think about that, guys. Why is it dy dx?
It's 1 dy.
Yes, because it's 1 and then times dy dx. So dy dx. And then the other side, what's the derivative of x? 1 minus. Yes. God, you understand. All right, so again, we're solving for dy dx, right? Okay, so I got to get all of those on one side. So I'm going to put it in the plus dy dx equals 1, and then that'd be plus y. Just moving stuff around there. Are you okay with that, guys? Derivative of y. So derivative of y would be 1, but since it was a y, we also have the dy dx.
Since it's also one?
Okay, so like, you get that the derivative of x is 1, right?
Yeah.
So the derivative of this is 1, except it's of y, so we always have dy dx attached to it when it's a y.
Oh, 1 times each x.
Yeah, I just... Alright, so I can factor out my dy dx over here, and I'd have negative x plus 1. Are you guys with me? A lot of this is just algebra. So we have that. You with me today? Is that what I asked you to find? No. I asked you to find the second derivative. So we now have to do this. What do you think I have to use on the right? Quotient rule. Alright. So, and if you want to rewrite negative x plus 1 as 1 minus x, that's fine. Yes.
So let's say we mess up the first derivative, but we get the second derivative right, if something wrong first derivative.
So there's definitely, like on the AP exam, there's follow through error. So yes, you could get partial credit. If, like for my test, if I see you just being like, well, I'm going to say the first derivative is 1, so I know the second derivative is 0, like that, I'm not going to give you credit. You know, that's not just follow through it. But if you just like screw up a sign somewhere, yes, I will absolutely give you partial credit. Alright guys, I want you to try to do the derivative of this. See what you get. Do the first step of your quotient rule, and then we'll look at it together, okay? Alright guys, did you get there? 1 minus x times dy dx minus 1 plus y times negative 1 all over 1 minus x squared? Okay. Didn't we find dy dx right here? Okay, so we can substitute that in. Okay? You're not like moving that guy to the other side or anything like that, because we still just want the second derivative. So you don't have to do anything on the left side of your equation. But I now have 1 minus x times 1 plus y over 1 minus x. And then I can go ahead and simplify this. Do you guys agree that it would just be plus 1 plus y? You see it? All over 1 minus x squared. We're close, guys. What's going to happen when I go to simplify this? Things are going to cross out, right? Do you guys see how these go away? Yeah? Okay. So I'm left with 1 plus y plus 1 plus y in my numerator. So what do I really have? Okay. Over 1 minus x squared, and that's it. So anytime with implicit, when you're doing that second derivative, you're going to have to plug in your first derivative. Yep, that's the beauty of it. right, let's try another one. Am I on 5? Is that right? dy dx. And your equation is y squared minus 3xy plus x squared. You guys try this one. You guys ready? Did you get 3y minus 2x over 2y minus 3x? Over 2y.
I never called it stupid. Oh, yes. Yes.
Alright guys, let's go through it. So for y squared, I'm going to have 2y and then dy dx, right? Okay. I'm going to think of this as like plus negative 3xy, and I'm going to really think negative 3x times y. I think that just helps you understand what's happening with the sign. Yeah? Well, it was minus 3xy.
Oh.
Yeah? Okay. Alright, so then I'm using product rule. So I'm going to have plus y times negative 3 plus negative 3x times dy dx plus 2x equals 0. Okay? So I'm going to do dy dx 2y minus 3x, and then this would be 3y minus 2x, just moving stuff around. Okay? So then dy dx 3y minus 2x over 2y minus 3x. Got it? Oh, Do you understand it now? The sneeze was good. Yeah. How many of you got it? 3. Okay. We're getting there. We're getting there.
I got it.
Got it? Good. It makes sense now? What? No assembly today. You get out early, but no assembly. Hey guys, the schedule's on the board up there on the left if anyone's not sure of what's happening today. Number 7th and 5th get pushed. So, really hope you like your 5th because it's still. Alright guys, any questions on 5? Any clarification on anything? Okay, let's try again. We'll do one more. What is the slope of the tangent line? X, Y, plus 2x, y cubed, 6 at point 2, 1. Alright. So guys, this is one where like you should get just a number at the end, okay? When I'm asking you what is the slope at a point, I'm looking for a numerical answer. So go ahead and try. Anybody have a number yet? No, okay. You do have to do the product rule twice. Yep, good time. So like this one, like look at your product rule here, you know, I'm just taking this times the derivative of this, so that's why there's no d by dx. But then when I do x times the derivative of that, there's going to be a d by dx. Okay. Guys, make sure you've got the derivative right before you plug in the point. Negative y minus 2y cubed over x plus 6xy squared. Okay. And then you're just plugging in that 2 and 1, so. How are we doing, guys? We are almost out of time, so I just want to make sure you know what the homework is before the bell rings. There is a worksheet that says homework 11-2. It's front and back of that, and that is it. Okay? No weird riddles, no 8 pages. Homework is just 11-2.
Oh, it's a 2, sorry. It's 2.
Okay. It's 12 plus 2. All right, guys.